Imagine trying to drive from London to Sydney in a car that only has enough fuel to reach Paris. You'd have to stop and refuel many times along the way, making the journey incredibly complex and time-consuming. This is the exact challenge SpaceX's Starship faces when aiming for the Moon or Mars. The spacecraft burns through most of its propellant just to reach orbit, leaving its tanks nearly empty for the journey beyond Earth. Without the ability to refuel in orbit, Starship would be limited to short trips within Earth's immediate vicinity, but with orbital refueling, the possibilities expand dramatically. This is why orbital refueling isn't just helpful, it's essential. The plan is to turn low Earth orbit into a cosmic petrol station, where tanker starships will launch, dock, and transfer their fuel, liquid methane and oxygen, to top up the main ship. After a starship reaches orbit, tanker starships will launch, dock, and transfer their fuel, liquid methane and oxygen, to top up the main ship. This process gives Starship the fuel it needs to break free from Earth and travel to the Moon, Mars, or beyond. Without refueling, Starship is limited to Earth's neighborhood. With it, it becomes a true interplanetary vessel. It could deliver massive cargo or cruise to the Moon, establish a base, or even make the 6-month journey to Mars. Every grand vision for humanity's future in space depends on mastering this one technology. For a single Moon mission, it might take 4 to 8 tanker launches, maybe even more, depending on how much propellant is lost to boil off. This demands a rocket that's not just powerful but rapidly and fully reusable. The entire system, rocket, launch pads, and refueling, must work together seamlessly. Imagine a future where refueling in orbit is as routine as stopping at a gas station on a road trip. This would revolutionize space travel, making it more efficient and opening up new frontiers for exploration. The ability to refuel in space could enable missions that were once thought impossible, allowing us to establish permanent bases on the Moon and Mars. It's not just about reaching these destinations, it's about staying there and thriving. Orbital refueling is the key to unlocking this potential. As we look to the stars, mastering orbital refueling will be the cornerstone of our journey, enabling us to explore, settle, and perhaps one day, call other planets home. The future of space exploration hinges on this technology, and with it, the universe is within our grasp. The entire system, rocket, launch pads, and refueling, must work together seamlessly. This is the future of space travel, and it starts with refueling in orbit. The dream of interplanetary travel is closer than ever, and it all begins with the simple act of refueling in orbit. The idea of an orbital petrol station is revolutionary, a concept that could completely transform how we explore space. Imagine a future where spacecraft can refuel in orbit, extending their reach far beyond what's possible today. This vision could make deep space missions, lunar bases, and even journeys to Mars far more practical and affordable. But it's also a giant leap into the unknown, filled with technical hurdles and risks that have never been faced at this scale before. Starship uses cryogenic propellants, liquid methane and oxygen that must stay extremely cold, just a few degrees above absolute zero. These fuels are notoriously difficult to handle, even on Earth, where gravity helps keep them settled and insulated. Transferring these in zero gravity, without them boiling away or freezing the lines, is an immense engineering challenge. Every step must be carefully controlled to prevent dangerous leaks or catastrophic loss of fuel. It's never been done at this scale. The sheer volume of propellant needed for a Mars mission is staggering, requiring dozens of tanker flights and flawless coordination. Docking is another hurdle. 2 massive starships, each the size of a building, must find each other and dock precisely in orbit, all while traveling at thousands of kilometers per hour. The transfer hardware, pumps, pipes, seals, must work perfectly and autonomously, with no room for error. Any malfunction could jeopardize the entire mission. Even with a high launch success rate, a mission needing many refueling events sees its overall chance of success drop. Each additional launch adds complexity, cost, and risk. Critics question the sheer number of launches required and whether the infrastructure can keep up with such an ambitious schedule. There's also the risk of delays or propellant boil-off, as cryogenic fuels are constantly trying to warm up and evaporate, even with the best insulation. If Starship's dry mass is higher than planned, it will need even more fuel and tanker flights, compounding the risks and stretching the limits of current technology. These aren't minor details, they're fundamental questions about whether the architecture is truly feasible, or if new breakthroughs are still needed. The complexity is daunting, but solving it is the only way to unlock the solar system. If humanity can master cryogenic transfer in orbit, it will open the door to a new era of exploration. making the impossible possible. Despite the skepticism, Elon Musk has set a bold deadline. SpaceX aims to master orbital refueling by 2026. He calls ship-to-ship cryogenic transfer one of SpaceX's hardest challenges, but remains confident. "I specialize in the impossible." The Starship V3 is at the heart of this plan, an upgraded rocket with greater propellant capacity and a hot staging ring for more efficient launches. V3's new Raptor engines and improved heat shield boost reusability and performance, critical for rapid, repeated launches. By tying the challenge to a specific vehicle and deadline, Musk is driving his team to innovate at breakneck speed. Whether they succeed remains to be seen, but the race is on. Docking two massive starships in orbit is daunting, but SpaceX isn't starting from scratch. Their Dragon capsule program has performed dozens of automated dockings with the International Space Station since 2012. The sensors, software and guidance systems developed for Dragon are directly applicable to Starship. While Starship is much larger, the core principles, precise navigation, LiDAR, cameras and thrusters, remain the same. The docking mechanism must be robust, able to handle both the physical connection and the transfer of tons of cryogenic propellant. Lessons from Dragon's airtight seals provide a foundation for Starship's more complex systems. SpaceX's experience gives them a critical head start. The scale is new, but the expertise is proven. SpaceX's journey toward orbital refueling is driven by a philosophy of rapid, incremental test flights, each one building on the lessons of the last. This approach allows the company to innovate quickly, adapt to challenges, and push the boundaries of what's possible in spaceflight. Among the most impressive recent milestones is the successful transfer of cryogenic propellant between tanks in zero gravity. This complex maneuver is essential for refueling spacecraft in orbit, a key requirement for long-duration missions to the Moon, Mars, and beyond. SpaceX has also managed to reignite its powerful Raptor engines while in space, an achievement that's absolutely crucial for deep space missions, where multiple engine burns are needed for course corrections, orbital insertions, and safe returns to Earth. Another major step forward, Starship's payload bay door has been tested and proven in orbit, demonstrating the vehicle's ability to deploy satellites, scientific instruments, and cargo directly into space, opening up new possibilities for commercial and scientific missions. The Super Heavy booster, which provides the immense thrust needed for launch, has now performed a successful boost-back burn and a gentle, controlled landing at Starbase. This is a huge leap toward rapid reusability and cost-effective space access. Looking ahead, the next big goal is the first-ever ship-to-ship docking demonstration in orbit, followed by a full-scale propellant transfer between two starships, an essential step for future interplanetary missions. Every test flight, every milestone, builds confidence in the Starship system and brings SpaceX closer to launching fully operational missions that could change the future of space exploration. The vision of Mechazilla, giant robotic arms catching returning boosters, is now within reach, promising even faster turnaround times and more frequent launches. With every successful test, the dream of interplanetary travel, sending humans to the Moon, Mars and beyond, becomes more tangible and more achievable. The countdown to 2026 is on, and with each passing day, SpaceX moves closer to making history. Orbital refueling isn't just a technical challenge, it's a manufacturing revolution. SpaceX is scaling up production at its Starbase Star Factory, aiming to mass-produce starships like cars, not custom projects. Automation and streamlined workflows are slashing build times and costs, making a large, reusable fleet possible. Multiple launch pads, including a new tower at Kennedy Space Center, will double launch capacity and provide redundancy. Rapid reusability and high launch tempo are essential for assembling propellant depots and meeting tight mission windows. SpaceX is building not just rockets, but the industrial backbone for interplanetary transport. The scale of this operation is unprecedented. Starship's refueling success will shape the future of space and global power. NASA's Artemis program relies on Starship as its lunar lander, tying America's return to the Moon to SpaceX's progress. Meanwhile, China is racing ahead with its own lunar ambitions. If Starship's refueling works, the US gains a reusable, heavy-lift edge no other nation can match. If it fails, China could claim the next lunar milestone. The stakes: American leadership in space, the first city on Mars, and humanity's expansion into the solar system. 2026 is the turning point. The fate of our future in space may rest on these orbital petrol stations.